coming. Alrighty, so there are like two main pieces or main ideas in calculus, and limits are going to help you get to the first one. Derivatives and integrals. And so we're hoping to hit both of those really hard this spring so that by the time you start AP Calculus next fall, you're good to go and you know all of the major pieces, and then you just have to put together all the details. And you're going to take it more in depth. Here's our introduction to derivatives. Before we sort of start talking about derivatives at all, I want you to do this one right here. And this looks real similar to stuff you've seen before. In fact, it looks exactly like stuff you've seen before. If we're finding the limit as h approaches 0, you can't plug in a 0 because why? Makes a 0 on the bottom, which makes it undefined. So we need to do some work to this thing. So we are going to rewrite this as the limit as h approaches 0. Yeah. Wait, what meeting did they just make an announcement or something? Or I missed something? I wasn't listening. I'm sure it's fine. Everywhere you see an x, you put in x plus h. So instead of x squared, we have x plus h, the quantity squared, minus 3 times instead of x, you have x plus h, and then minus 2. So this guy right here goes with this guy right here. And now we're subtracting the function itself. So it needs to be in parentheses because that negative affects everybody. Are there any questions with how to set that up? Because you're going to have to do that about 100 times. Not really, but you're going to have to do a bunch today on your assignment. Everybody okay? And then we just sort of do some Algebra 1 to kind of simplify the whole thing down. And that's, whoops, that says limit, sorry, limit as h approaches 0. And that's kind of where some of you guys went wrong on your test. A lot of you guys don't know how to FOIL this. It is not x squared plus h squared. If you do first outside, inside, last, you get x squared plus 2xh, whoops, plus h squared. Distribute the negative 3. Distribute the negative. Then you can start to simplify some things down. I've got an x squared and a negative x squared. I've got a negative 3x and a positive 3x. I've got a negative 2 and a positive 2. And just so we're not going to cross-eyed and just so I can make sure everybody's on the same page, I'm going to rewrite what I've got left. So I've got a 2xh plus h squared minus 3h, and the whole thing is over h. Aurora, what do we do next? Yeah, we can take an h out of everybody. And whenever we say take out an h, you do remember that you are dividing. So we're dividing by h, dividing by h, dividing by h, dividing by an h. So that what we have left is the limit as h approaches 0 for 2x plus h minus 3. What's your next step? Yeah, now you can plug in 0. It's totally legal now that that h is off the bottom. So when I put in a 0, the answer I get, and notice the way I'm going to write this, f prime of x, transitioning you to your new stuff, is 2x minus 3. And initially, I think whenever we did this, you thought it was strange there was still a variable in the answer. And there is still a variable in the answer. That's okay. What kind of graph does this thing make? A line. It makes a line. And so we are looking for something like that today. And here's why. Let's see if I can transition this a little bit easier. Where's that PowerPoint? Okay. So let's see here. We've got this funny little joke. Sun tanning. Tangent. Sunblock. Haha. They needed a whole bunch in the desert. And here's your tan gentleman. Honey, could you please rub some suntan on my lotion on my nose? I feel like it's kind of burning. that's not really what we're looking at, but our tangent definition, when we think of tangent, we think about a line in a plane of a circle. It intersects at exactly one point, and that's what you're familiar with this piece right here, that you've seen before. This down here, let me back up so you guys can see this. It says we wish to enlarge on the idea to include tangency to any function. So this line if it's tangent to this crazy curve, it's not always going to be at this angle. It depends on where the point is that we're tangent to, right? The slope of a line tangent to a curve is approximated by secant. That's where you have 2 points of intersection. You see these 2 red dots? I bet we could get those dots closer and get a better, more tangent looking line. Do you see how the dots are closer? Now that slope of a line is probably a little bit more accurate. And we could pull those 2 dots even closer and get that line a little bit more accurate. It says let the second point get closer and closer to desired point of tangency, and that's what we were just talking about. Here's your animation. You see that blue line? It's constantly changing, depending on what point we are trying to be tangent to. Do you guys remember at the beginning of the semester we talked about increasing and decreasing intervals? You look at decreasing intervals here from -20 to about, I don't know, -7. Look at this blue line. Those slopes are all what? Negative. What are the slopes on an increasing interval? They're all positive. That increasing, decreasing stuff may come back to bite you, so just be ready for that, okay? Let's see here. We're going to recall the concept of a limit from our previous chapter. We're going to use the limit in this context. As this point is getting closer and closer and closer, remember limits? We're approaching a value. Well, we are approaching a value to figure out tangent is what we're doing. Let me see if there's anything else I really wanted to pull out from this particular deal. This is a really good PowerPoint, but I don't love all of it. So let's see here. You can kind of see here they're letting delta x, or the new x, shrink from the left, and as it's shrinking, you can see that line, that blue line, is getting closer and closer to that tangent line, which you can't even see blue probably on the board anyway. All right, so let's back up here. We've got kind of a picture going on here. This is our secant, and let's say that this blue curve right here, mine's blue, yours is probably just black and white. Let's say it's this guy right here. It's that green one that's being curved. We've just zoomed in on it. And when we zoom in, over here it looks like that line is tangent to that curve, right? What's really happening is that you've got a couple of points. And it doesn't matter how close you keep pulling those points together, you're still going to have a gap and it's still not going to be exact. We're going to get it as close as we can. If I'm trying to find the equation of this line right here, or the slope of that green line right there, you guys remember how we did difference of the y's over difference of the x's? Yes? This point right here is at the point x plus h, comma, f at x plus h. That's your y value. So I've got the y value of f at x plus h minus my other y value, which is f at x, over the difference of the x's. So I have x plus h, that's my y sub 2, or x sub 2, minus x sub 1, so minus x. And that's how you find slope. And this looks super duper similar to something we've been doing. So when you've been finding the limit as h approaches 0, you've been finding that tangent, that slope. The formula for slope is what you've been doing. And you didn't know it. What's x minus x? 0. They cancel out, so you're left with an h on the bottom. And that's that exact same formula we've been messing with. Let me go to some other kind of pictures here. These animations, for some of you, it may be really helpful. For some of you, maybe not so much. Here we go. Sorry, well, that's student council. It's coming. I hope. It says it's coming. There we go. You guys can probably barely see that. Do you guys see that red parabola there? Can you see that really faint blue line right there? As I take this dot and as I pull it in closer and closer and closer to the dot in question, that line, the slope changes and I'm getting closer and closer and closer to tangent. And that's what you're doing, is it's a limit. As you're looking for that formula for slope, it's a limit. You're getting closer and closer and closer to that point. Let's see here. Whoops, I can minimize that. Let's try this one. This is a different curve. It's not a parabola. This one's going to pop up. It's kind of like a sine wave, but it's increasing. It's kind of like mountains. Do you guys kind of see that?
Yeah.
It's kind of hard.
I see it.
This is going to follow it. You guys kind of see that tangent line changes. So that tangent line, it depends on what x is. Depends on what x value, where we are, would determine what that tangent line looks like, right? Great question. That big dot, let me go back. Nope, we're over here, just kidding. This big dot is the value of the slope. So like, at -6, the slope is about 2.5, and that's why it's at -6, 2.5. Right here, horizontal line, it's at 0, right? So the x value on this one is -5, the slope is 0. So as you watch that red dot, it's kind of bouncing up and down as well because the slope is bouncing up and down. Good question. Let's do one more here. Let's see if this helps at all. Okay, I can't make that any bigger. I don't know how, or it won't. On the left-hand side over here, you can tell that we're kind of closing in on that tangent line, finding the limit. On the right, it's showing you what that looks like as you close in. As you zoom in, you see this purple line right here?
Mm-hmm.
It's curved and it looks like it's going straighter and straighter and straighter. It's because you're zooming in closer and closer and closer and closer. And so that's kind of what's happening for us. And then, what else was a good one? These are okay. Whoops, blinking at me. Why is it blinking at me? Here we go. So you can see kind of that tangent line is changing based on the curve. I think that's a pretty good video. You guys can see the colors. Okay, so let's go back. Talk about this sort of mathematically, what this means is. Next page. At the top, the derivative. So you're thinking, what is a derivative then? I don't really understand. One way to say it is that the derivative of a function is the slope of a curve at a point. I like that definition, but for some of you, I think this other one's going to make more sense. We could say that the derivative is a formula. It's a formula for, oh, you know what? I just gave all of my little keynote to Alex. I don't have any of them. Okay. It's a formula for finding the slope of a tangent line at a given x. It's a formula for finding the slope of a tangent line at a given x. And I think that'll make more sense kind of as we get through here. You can kind of see the progression of what's going on here inside the box. We've got m equals difference of the y's over difference of the x's. That's algebra 1. You've seen that before, and that's the definition of slope, or that's the formula for slope as far as you knew it. What we've started doing is, and this is what I just showed you, this is the limit that you've been finding where x minus x is nothing, so you have 0 on the bottom. You've been looking for the slope. Another way to write it is this little guy right here. This will have to be memorized, and I'm going to interchange the way that I write about it. For calculus, some professors use the left one more than the right one. Some use the one on the right. This little notation right here, you say f prime of x. Prime of x. The little guy on the right, you're going to say the derivative of y as it relates to x. That's going to be more important later. The derivative of y as it relates to x. So when it asks you to find the derivative, it's asking for the formula for the slope of a given point. Now, you and I both know that y equals 7 makes what kind of line? What do you mean by straight? Horizontal line, right? And what's the slope of a horizontal line? 0. We're going to use calculus to get that same answer. So we have the limit as h approaches 0. And again, this little red cloud here, you have to have that memorized. Memorize. So we're starting out with the function at x plus h. So everywhere I see an x, I put in x plus h. Where's the x? Don't have one, so we write 7. Minus the function itself, so minus 7 all over h. You can't put in a 0 because h is on the bottom. So we have the limit as h approaches 0 over h. So if you think about the limit as we're approaching that little guy, we've got our little t-chart. At 0, we don't know, it's undefined. But if I put in negative 0.001, what's 0 divided by anything?
0.
And if I have positive 0.001 and I plug that in for h, what's 0 over anything? So, what we're saying is that f prime of x, the derivative, is 0. All right, let's look at the next one. You know that makes a line, and you can anticipate what's the slope. Negative 8. We're going to prove it using calculus. So here we go. Limit as h approaches 0. Okay, we start out. Everywhere we see an x, we put in x plus h. So negative 8 times x plus h minus 2. Minus the original function. Negative 8x minus 2 all over h. Let's do some algebra to simplify this little guy. So we have negative 8x minus 8h minus 2 plus 8x plus 2 all over h. Then you can cancel some stuff out. Negative 8x and positive 8x. Negative 2 and positive 2. H goes into h1s, h goes into h1s, and you're left with, wait, I forgot, yeah, negative 8. So we have f prime of x is 8. So it doesn't matter what point you choose on that line. Yep, negative, thank you. I thought something was weird on that. Thank you, it's still negative. Doesn't matter what point you choose on that line, the line tangent to it is going to be negative 8. Yes, sir?
So if we write the answer, do we have to put that down?
I think it is a great habit to get into because things are going to get really complicated really quickly and you're going to have that. So yes. Great question. Alrighty, let's keep moving. This one's a little bit more complicated. It's got some curve. So it's not like you can just look at the equation and figure it out. We use the calculus. So same process. We say the limit as h approaches 0. Everywhere I see an x, I put in x plus h. And we subtract the function itself. The whole thing is over h. Do some algebra. Remember, that's not x squared plus h squared. You have to FOIL that so that we get x squared plus 2xh plus h squared. And then we can add h, or plus x plus h minus 2. Subtract everybody, so we have negative x squared, negative x, and positive 2. You can simplify some things down. So the x squared and negative x squared go away. Positive x and negative x go away. Negative 2 and positive 2 go away. And just because this is my notes and I don't want to make myself crazy, I'm going to rewrite this. So I have 2xh plus h squared plus h all over h. What do you do next? Cancel your h's. So we divide out an h, divide out an h, divide out an h, divide out an h. What did I forget? Thank you, there's a 1. When you are reducing or when you're canceling, you're actually dividing. So there is a 1 there. So what I'm left with is the limit as h approaches 0 for 2x plus h plus 1. Now you can plug in your 0. So the f prime of x, or dy over dx, equals 2x plus 1. This is not the exact line that is tangent to that curve. It depends on what x is. Once you plug in that x, that gives you the slope of the line at that place. All right, you guys do the last one on your own. Good question. Let me go back and look. Yeah, it was a -3. So it's just -3. Good question. You guys do the last one on your own. If you need to sneak a peek and look up here, you can. Try to do it on your own. It's okay. You're right. From the left. Great question. Yep, from the left. Oops, minus, sorry. From the top, you had to multiply the top and the bottom by the conjugate in order to get rid of those radicals. The roof came off the top of this one. When the roof came off of x minus 3 and you were subtracting the whole thing, I went ahead and distributed it at the same time. So I have minus x minus -3 is plus 3. All of the major players canceled. Our h is also canceled, but don't forget that there's a 1 on top because canceling is dividing. A lot of you guys forgot that on your test and just gave me the answer that was just a denominator. So we have 1 over this guy here. Now you can put a 0 into h, perfectly legal. And I'm fine if you just leave it like this. If you want to rationalize it, you can, but we're just looking for a function, and then later on today, actually, you're just going to end up plugging something into x anyhow, so I wouldn't mess with rationalizing unless you just really want to. So I've got 1 over, this is really x minus 3, because that h is gone. This is x minus 3. I've got 2 of them. How are we doing? Is everybody okay? Any questions? Okay. So that's just giving us the formula to find the slope of the tangent line. Here's what they're going to ask you today. says to find the slope of the line tangent to the graph at the given point, then find the equation of the tangent line at the given point. So you're going to have to use limits, you're going to have to use your derivative to get to your answer, but the derivative itself is not the answer, so don't box that. I want to make that very clear. I want to make sure you know the difference. So the first step is to find the derivative. So we have the limit as h approaches 0. Everywhere I see an x, I put an x plus h. So I have x plus h, the quantity squared, minus 9, minus the original function, so minus x squared minus 9, all over h. We use our algebra to give us x squared plus 2xh plus h squared minus 9. Distribute the negative all over h. Positive 9 and negative 9 go away. Negative x squared and positive x squared cancel each other out. Take out an h, take out an h, take out an h. So now I have the limit as h approaches 0 of 2x plus h. If I put a 0 into h, the derivative, my answer there is 2x. And remember, that is a formula for finding our answer. It is not the answer. So once we have 2x, you're going to take this x value right here, and we want to know what that line looks like right at negative 1. So you're going to find f prime of at negative 1. So we say 2 times not x, but 2 times negative 1, and we get negative 2. So if you were to graph that slope right at negative 1, and then you drew a line tangent at negative 1, that slope of that line would be negative 2. So there's your first answer, because it asked to find the slope. We did. Now you can put a box around it, but you've got another answer you have to find. It says now find the equation of the whole line at that given point. All right, I know it's been a while since Algebra 1, so you might want to write this down with a little star by it. Y minus y sub 1 equals m times x minus x sub 1. You guys remember what that's called? Point slope form. So we're going to say y minus the y value, which is negative 8, equals m, we found the slope to be negative 2, times x minus the x value, which was negative 1. So we have y plus 8 equals negative 2 times x plus 1. And that's your answer. If you want to leave it in point slope form, that is fine. If you would rather use the slope intercept form, that's fine as well. So this is the equation of the line that's tangent at the point negative 1, negative 8 for that function. Questions? You okay?
Yeah.
Okay. How are we doing? You guys are really quiet.
Yeah.
All right. You've seen the process. You find the derivative. You plug in the x value. There's your slope. Use the point slope formula. Plug in both values, and you're done. Use that process on the last one. Go. It's fun, right, Nick? Not so much? Well, if it makes you feel any better, in a few days you're going to get a shortcut. But not today. Nope, you do have to know the long way. You really, really do. It'll pop back up. Oh, this is an H. I couldn't figure out what was wrong with that. Sorry. So once you put in your X's and your H's, a bunch of stuff cancels. Got this guy left. Put in a 0 for your H, which means that H goes away. So I just rearranged the order on this. I have negative 2x plus 3, which is not your answer. That's the formula for finding the slope. So now that you have your formula, the x value they wanted you to find was 0, so I plugged in my 0 right here. That's why it says f prime at 0. I'm naming what I'm doing so that the reader knows what I did. Plug in 0 and you get 3. That means that's the slope of the tangent line at 0, 0. Now I need the equation of the whole line. So we say y minus y sub 1 equals m times x minus x sub 1. And we get y equals 3x. And that's the equation of that line. Say again? No, it's not simplified. Yeah, but y minus 0 is y. Anything minus 0 is itself.
Okay, do we have it y equals 3 times x minus 0? Like, I don't know what this is. That's what we did.
Because you know what x minus 0 was. It'd be like if you gave your answer to me as, oh, and this happened, by the way, on that right there. You gave me the answer like radical 1. What is the square root of 1? 1. You have to simplify.
But couldn't we simplify the one before?
The one before was simplified.
So couldn't you like distribute it?
Yeah. You can rearrange it and put it in slope-intercept form if you want. But what I'm saying is that you know what y minus 0 is. It's y. So you can't leave it at y as y minus 0. It's not simplified. But you couldn't, like, the reason I didn't put it together over here is because you can't add together y and 8, or whatever that was. You can't add y and 8. Those don't go together. You can distribute, but this is also considered simplified. Okay, does everybody but Ocean see what I'm talking about here? It doesn't matter. Either form.
I don't get how you distribute all this.
You can. Carson, you totally can. If you want to do this, go for it. So we have y plus 8 equals negative 2x minus 2, right? Subtract 8 from both sides, and you have... That is also the answer. Both of these are the same answer. One is not simpler than the other. In this case, this one is simpler because you know what y minus 0 is. It's y.
But you distribute it. You don't actually.
Well, honey, if you have x minus 0, you know that's just x, right?
Yeah, but I also know.
I think you're being difficult. I think you know what I mean, and I think you're wasting time. Let's move on. Differentiability. Next page. When something is differentiable. That means basically that you have a derivative. Differentiable means it has a derivative. For a function to have a derivative, the limit at 0, or as h approaches 0, has to exist. If that limit doesn't exist, then it's not differentiable. It doesn't have a derivative. Here are 3 special cases where the derivative doesn't exist. If there's a sharp corner. We know that this slope right here is negative 1. We know that this slope right here is positive 1. And as you come in with 2 points, right at 0, you're not going to be able to get that tangent line. So we say at x equals 0, it's not differentiable. Also a cusp for the exact same reasons. So right here at x equals 0, it's not, we won't have a derivative. The next one's a little bit different, a vertical tangent. Why right here at A do we not have a tangent line? Thank you, the slope is undefined. Those are the three special cases. The other one is a little bit more obvious, but if there's any discontinuity, obviously, like if there's a hole or vertical asymptote, you can't have a tangent line at an asymptote. That doesn't make any sense. So if there's a discontinuity, then of course it's not differentiable at that place either. Last little bit. Differentiability implies continuity. If the function is differentiable at x equals c, then the function is continuous at that same point. Is the reverse true? If it's continuous, is there a derivative? Is this continuous? Is there a derivative all the way through? That one doesn't have a derivative. So the converse is not true. Well, it's because I circled it. And same for a cusp. This guy right here, continuous all the way through, but right at A, we don't have a derivative. It's going to be an undefined slope. So the converse of this is not true. Make sure you know that. And that may show up sometime. Alrighty? Okay, that's the bulk of today's stuff. Let me give you your assignment. Do I have the assignment up? Nope, I don't have it up. I got to find it. Let me turn this off.